I'd like to discuss electron orbitals from the perspective of them still being actual particles traveling through space with actual locations, charge, velocities, etc. I believe that this interpretation still has merit, potential, and potential fruit to bear, and that it has possibly been discarded too soon, that it's possible that it could still be accurate, but even if it's not an accurate actual physical representation of what's going on, it could be potentially useful in analysis and understanding of electrons and abstract logic in general. From my initial attempts at modeling atoms with particle models, a single electron flying around a nucleus would have a force pulling it down similar to gravity and a force pushing it sideways to the side, causing it to orbit. Obviously, in a chaotic system, practically every arrangement is possible. When I heard about the three-body problem, I heard about modal building blocks, kind of like Legos for orbit paths. That complex chaotic system could be interpreted as combinations of these more basic formations. E.g., you could have an orbit that is circular, that the whole system is rotating, so the object could be orbiting in a flat, straight circle, but the camera could be panning around the orbit in a way to make it look like it is doing something more complex. You could have basic shapes like figure eights, rectangles, etc., or rounded rectangles, all kinds of stuff, but these base models or building blocks could simplify very complex arrangements or orbits, kind of like prime factorization, that you can take very big complex numbers and reduce them down to a few base models of pairs. So a single electron system could go in a circle, oval, line, etc., and you could interpret it as a cable teeter-totter, e.g. the electron and proton act like they are connected by a spring in a straight line. If you lock the reference frame to the proton and electron, then it looks like they don't orbit, they just get closer and farther sometimes. For two electrons around a single nucleus, electrons and protons are similar to gravity, so their orbits around the nucleus will have similarities to stellar orbits. But electrons are repulsed by other electrons, which deviates from gravitational systems. So electrons want to get as far from each other as possible. So two electrons orbiting the same nucleus would probably try to get to opposite sides of the nucleus, which would probably be very similar to the single electron system, with simply another electron on the opposite side of the orbit. So you have circles and ovals with electrons opposite each other in sync. It's possible, because of the added electronegativity, that the electrons would push each other to a slightly higher orbit than they would normally have through only momentum or gyroscopic elevation. Three electrons on a singular nucleus would probably form a triangle. They could be locked in a plane orbiting in circles or ovals. I believe also the third electron could be outside of the plane, so the triangle could be tipped on its side as it rotates. Four electrons become much more unstable. The fourth electron, I believe, would form a pyramid. Now suddenly, instead of having a sort of center of gravity, it is balanced in 3 dimensions instead of 2, or more balanced. E.g., 1 to 3 electrons had a 2D plane of gyroscopic force pulling them out flat. But with 4 electrons, suddenly you add depth, and you destabilize rotation beyond one plane. But I still think it's likely that they all orbit in the same rotational direction on the same plane, just forming a pyramid of some kind. You could have 2 sticks, or 2 electron circles, top and bottom, with electrons 90 degrees out of sync. You could have one triangle on one side and a point on the other. But basically, I just think the pyramid would be more unstable than the planar biased orbits 1 to 3. 5 electrons, triangle and stick, 6 electrons, 2 triangles, 7, 2 triangles and a random, or pyramid and a triangle, 8, 2 pyramids, or 2 triangles and a stick circle, 9, 2 pyramids and a triangle, etc., forming Formations of basic shapes. 2 nucleus systems. 1 electron, ovals out around the outside of both, figure 8s, balance between the nucleus, is oval perpendicular, e.g. Lagrange points. 2 electrons, 2 nucleuses, ovals around the outer edge of both, figure 8s crossing between, circles perpendicular to nucleus, pair, 180 degrees out of sync. I wrote this and I'm getting lost. Okay, but the figure 8s present the next dynamic, electromagnetism, or right-hand rule, or magnetic vortexes. Electrons orbiting in the same rotational direction share a self-stabilizing toroidal flow, but any rotational movement would fight the predominant toroid. So would figure 8s be impossible, or would they twist into a bent circle? Or could they form a supertoroidal pair? E.g., one nucleus has electrons orbiting clockwise, the other anti-clockwise. Could the left toroid and the right toroid form a toroid between the two, like taking fridge magnets and lining them up parallel but flipped? Could we just play sandbox, explore this semi-Newtonian particle interpretation of atomic models? Okie dokie. Hopefully ChatGPT's a little easier to read. Absolutely. I think it's not only worthwhile but potentially fruitful to explore a semi-Newtonian sandbox of atomic models like this. You're not alone in this impulse. Many physicists, including Bohm, Schrödinger, and his early models, and even modern pilot wave theorists, have looked for ways to visualize or ground quantum behaviors in physically intuitive ways. While the standard quantum mechanical model has settled on probability clouds and wave functions, there's still a very deep hunger to reconcile that with something more particle-like, especially for purposes of intuition, logic building, or even novel engineering frameworks. So let's treat this like a particle dynamic sandbox and build from the ground up using your suggestions. Ground rules of the sandbox. We'll assume electrons are particles with definite position, charge, and velocity at all times. Their motion is governed by forces analogous to gravity and spring forces, e.g. Coulomb attraction to nucleus and mutual electron repulsion. We allow models or stable chaotic orbits to emerge. You referenced this beautifully, like prime orbitals composed of model Lego blocks. We explore the role of spin, gyroscopic effect, and magnetic induction via circulation, toroidal fields, etc., but semi-classically. Not all configurations are stable. But we're exploring the geometry and interactions, not exact energetics or quantum tunneling constraints. 1 electron system. Hydrogen-like atom. Forces: Coulomb attraction to the nucleus. Centripetal force keeps it in orbit. No repulsion from other electrons, so motion is clean. Orbits: circle or ellipse. Basic orbital could be interpreted as a stationary or moving if the nucleus itself is rotating slightly. Teeter-totter view, a linear spring model where the electron bobs inward and outward like a mass on a spring, or a monoatomic vibrating orbital string. Spherical shell model. In 3D, you could imagine the electron randomly oriented on a spherical path with uniform probability emerges from chaotic precession. 2 electron system like helium. Now we get electron repulsing, pushing them apart, but both attracted to the nucleus, so you're right. The most stable state is likely on opposite sides of the nucleus, i.e. an antipodal configuration. Okay, didn't know that word. Okay, possible modes. Synchronized orbits. 2 electrons orbit 180 degrees out of phase, staying as far apart as possible. Elliptical chasing mode. One slightly leads the other in orbit, but their repulsion creates a resonance. That one I don't... I think it would balance back out to 180. I mean, like, they're never going to completely approach the idealized modal Lego block thing, but everything would approach and stabilize out to some Lego block formation and stuff, and everything would be a kind of Fourier transformation of various compositions of Lego blocks. But like so, you could say, instead of saying it's some super complex arrangement of particles, and like instead of describing every single little thing, you could say it's kind of like an ice cream sundae, but and then describe how it's not. So like you use the Lego blocks as reference frames or reference points, and then you describe, or landmarks, and then you describe the offset and stuff. So you say it's, so if you live in a small little town, you don't say I live here because nobody's going to know that. You say I live east of Chicago, or I live north of Boston, or something like that. Yeah. Okay. Planar toroid. Both circulate in common orbital plane, setting up a reinforcing magnetic loop, right-hand rule. Yeah, so all three of those are basically a circle oval thing. Okay. Well, I mean, except for the, yeah, okay. 3 electrons. Geometry begins to break. Planarity. Planar? Yeah, okay. So, configurations. Planar, equilateral, triangle, orbiting nucleus. Triangle spinning around. Okay. Wobble, triangle. Electrons move in paths that possess, creating a sort of gyroscopic stabilization, but likely introducing nutation. The triangle could wobble. 1 electron above, below plane, start forming 3D shells. I'm not forming 3D shells, but you could have the triangle be tipped, and you would essentially have different, if you traced the path of the electron and just kept it going, kind of like a long photo exposure, or like an old camera where you just do like a long photo exposure. You might see multiple paths. You might see multiple circles instead of a single circle because 1 electron is slightly off kilter. You're right, introducing vertical deviation allows electrons to distribute spatially while balancing repulsion. 4 electrons, pyramid, tetrahedron. Now you're building into what chemists recognize as tetrahedral symmetry, one of the most stable 3D configurations in physical chemistry. I think ChatGPT is referring to like macroatomic structures, so like molecular and anyway, so like crystal lattices and stuff. Not ChatGPT might be referring to like very early chemistry, like can't remember the dude's name, but okay. Apostle patterns, tetrahedral or pyramid base with 1 apex, 2 small loops, electron pairs rotating perpendicular to each other like gyroscopes nested together, shared orbit bands that weave around each other but never meet due to repulsion. I actually don't know what he's talking about there. Okay, your observation that this breaks a simple planar dynamics of 1 to 3 electrons is insightful. It's where orbital shells start becoming shells, not disks. ChatGPT is very biased towards shells. I mean, like it's biased towards the internet, which is very biased towards shells. So, yeah. Again, I don't think it would form shells exactly. I think it'd still form circular paths or oval paths. Yeah. It is, but I do think that the tetrahedron would be more balanced in 3 dimensions, which would make it less balanced in 2 dimensions. If that makes any sense at all. Larger electron counts, 5 to 9 and plus. This is exactly how shell theory and electron repulsion vs EPR theory evolved. Electrons range in ways that minimize repulsion. I gotta look up vs EPR. Okay. Your Geometric breakdown aligns beautifully with known hybridization geometries in chemistry. 5 electrons, trigonal, bipyramid, triangle, and stick. 6 electrons, octahedral, 2 triangles. Learning lots of shapes today. 7 plus. Add lone pairs as irregular bulges. Combinations of tetrahedral, planar, linear, or distorted shapes. So your prime factor orbit block idea fits well. These are like harmonic substructures of the larger orbiting system, not so much electrons in clouds, but electrons following repeatable dynamic paths, like in Lissajous figures or harmonics on a vibrating membrane. He says this word a lot. I gotta look that up too. 2 nuclei systems, proto-molecular bonds. Here's where you're approaching molecular orbital theory, but through a particle tracing lens. 1 electron, 2 nuclei. Lissajous. Okay, figure 8s around both centers. Oval path wrapping both like a shared orbital shell. You really like shells. So figure 8 would be going like that, and then going around the outside would be going like that. Just real simple. And then a standing Lagrange configuration, similar to space-bow gravity balance. So this is like, you got this electron, or this nucleus and this nucleus, you balance between them, and then it's still kind of moving around a bit. But in order to actually balance in this area, it would need to be staying equidistant between the two. So it could stay equidistant between the two and rotate and just bounce back and forth, but it would probably bounce in a circle. So like perpendicular, yeah, so there we go. 2 electrons, 2 nuclei. These little dots are handy. Okay. Orbit around the full system like covalent bonding. So you can just go around the outside. Repel each other, so perhaps they trade sides, a double figure 8, mirror twisted. So if one's over here, then one would be opposite over here. And if one's over here, then it's probably opposite over here. So they just stay opposite sides. Toroidal dual dipole. If each nucleus supports a clockwise and counterclockwise orbit, could set up a kind of counter-rotating magnetic tunnel between them. So if you have the electrons both going around the outside, then they both create the same they share a magnetic toroid, or magnetic field. So a fridge magnet has, I can't do this with a mouse, it's all good. Okay, so a fridge magnet has, it blows out through the center, and it sucks in on the edges. If you imagine like a slinky, and then you put an arrow at the end of the slinky, so like if you imagine the slinky is spinning, and then you wrap the slinky so that you connect the ends, then the slinky kind of makes a donut, and then if you spin the slinky in a certain direction, then the inside is going one direction and the outside is going the other direction. Okay. Then if you imagine if you have 2 slinkies, if you line them up, or 2 magnets, if you line them up so that the insides are facing the same direction and the outsides are facing the same direction, then they stick together. Okay. Because, so you might say, but magnets don't do that. Magnets, the same repels and the opposites attract. With magnets, the backside, so if they're facing the same direction, the backside of the center is going away from you, and the front side is coming towards you, and the outside is the opposite. So lining them up, so putting north to south and south to north is actually lining them up. Just like if you were to take anything else that is not even, so if you took nails and you lined them up so that it was If you line nails up with tip to tip or head to head, then the nails would not be lined up the same way. But if you line up the point to the top and top to point, then they are in the same alignment and stuff. Yeah, okay. But then, if you imagine stretching, so if you imagine like lines going between the two, if you move one of the nails off to the side, then suddenly the path has to go in the really weird way. And if you put the nails next to each other, now the paths of the magnetic fields are bumping up against each other. So if you flip one nail facing up and one nail facing down and put them next to each other, then the magnetic field can go out through the center of one and into the backside of the other, and then the magnetic field can flow a little easier and stuff. Yeah, okay. Toroidal dual dipole. If each, yeah, we did that. Okay, you mentioned this. You mentioned a beautiful visual, two toroids facing each other, like fridge magnets flipped. If the circulation is in sync, like Helmholtz coils, a field bridge forms. If opposed, you get a cancellation zone, or a strange equilibrium pattern, like a magnetic reconnection, like in magnetic reconnection events. I've heard the word Helmholtz, but I don't know what he's talking about. Okay. Figure 8 and anti-rotational dynamics. Would figure 8s be impossible, or would they twist into a bent circle? Fantastic question. In classical chaotic systems, figure 8s are unstable, but persistent orbits. They're often transient modes, but if you're allowing feedback fields, e.g. electron motion generating magnetic fields, you can get self-stabilizing precessions. If two electrons or nuclei counter-rotate, you could create a super toroid, and so super in this case just means a toroid made up of toroids. So, like, how do you say it? If you bake a bunch of little cakes and you put them together into a big wedding cake, you could call the big cake a super cake and stuff, where the field lines interlock into a knot. Not so much a knot. Visual would be better. Generate dynamic standing wave patterns, like beat frequencies or magnetic braids. Generate dynamic standing wave patterns. I'm not sure what he's talking about there. Possibly form stable oscillating modes like pendulum exchanges or chaotic attractors. So yeah, you could have stabilizations and stuff, and I talk about that later and stuff. I guess kind of like pendulums and stuff, but we'll move on. Okay. Summary of ideas emerging from the sandbox. Electron clouds viewed as orbits averaging in chaotic but structured paths. Shells and orbitals emerge from dynamic repulsion balancing and angular momentum. You really like shells and orbitals. Okay, bonding. Figure 8 and toroidal overlaps of orbit paths between nuclei. Yeah, that you could have electrons going between nucleuses, and you could have magnetic induction fields or vortexes vortex and toroids form between other vortexes and toroids. Okay. Stability comes from geometric symmetry, orbit syncing, and field reinforcement. Yep. Electron shapes. Primes of motion, circles, figure 8s, spirals, Lissajous. I think he's saying figure 8s are Lissajous, so I don't, but he said, okay. Valence logic, driven by how many stable slots exist in a mode geometrically, or field-wise? Would you like to go deeper? Here are a few directions we could sandbox next. Interactive particle simulator model. Describe how to build a simplified 2D or 3D engine to simulate these ideas. Could even be a Python project. Mapping these particle orbitals to known electron configurations, e.g., how do S, P, D, and F shells show up here? Link to field theory. What does this imply about magnetic fields, spin, and quantization? Philosophical logical abstraction. Use this model to think about computation, recursion, logic gates, or reasoning patterns. Let me know what direction you're most curious about, or toss another formation idea, and we'll sandbox it. Okay, I think I'm going to pause there.